Hello everyone, welcome to our next CL tutorial. And in this tutorial, we're going to talk about step response in RL and RC circuit. Okay, so firstly, let's start with RL circuits. Firstly, I'm going to write the formula for finding IT, function of current, in RL circuit. So in RL circuit, function of T equals to I infinite, K, plus I0 minus I infinite multiplied e to the power t over r, theta time constant. So as you see, in natural response, there wasn't this and this. So that means we have to find one more expression, I infinite, okay? So when you have step response, there is always voltage source before switch is closed, okay? So in this case, as you can see, 24 voltage. This is voltage source, and this is before T is closed. Actually, after T is closed, sorry, after switch is closed, after T0, you have voltage source, then that means you have to solve for this formula. So step response, let's write step response when voltage after voltage source, let's say, right, after what? After T equals 0. That means after switch is closed. So firstly, let's consider the case when switch is opened, I mean before T0. So let me redraw this part. So what do we have? As initial case, we have to find I0, right? I0 equals I this, I this, okay? So this continuity, sorry for background noise. So I'm drawing before T equals 0. So this we will have this part, inductor, and then we have resistor, and what? And we have what? And we have current source. So 6, 8A, and 10 resistor. So as you can see, before, as you know, before T equals 0, that means from minus infinite to 0, we can say that d v dt equals 0. So when voltage 0, when there is short circuit, right? So that means we can replace this inductor with short circuit. Okay, so short circuit, resistor, and there is current source. And we have in this direction I, this I is what? I0, okay. So we can tell me what will be the direction of this current. Will it go up or this part? So please remember that current always goes through the path when there is less resistance, okay? So in this case, there is a resistance, so there is no point to go there because there exists a way where there's no resistor, okay? There's no resistance. So a direction will be up. So what's the value of I? Value of I is going to be minus A, because this is going to up, the direction is just down. So we have successfully found I0, right? So now, okay, this was a case when T equals less than 0, okay, it's less than 0. So let's consider the case when T is bigger than 0. I mean the case when the switch moves to the B, okay, from A to the B. So let's consider this part now. Let me redraw the diagram. So we have here inductor, right? And there is resistor. It's a 2 ohm, it's a 200 millihenry, and 24 voltage. So firstly, we find what? Time constant, okay? So please remember, firstly, very first thing you find is I0, then time constant, then I infinite. Okay, so time constant, as we know, is L over R. In this case, 200. It's an in RL circuit. 210 minus 3 over 2. It's going to be what? 1 over 10. Okay, 1 over 10 seconds. So this is just after t bigger than 0. Okay, but you know, when t equals infinite, what will be the case? You know, when t is infinite, we can replace inductor to short circuit, right? Just here, we replace before t equals 0, before t equals 0 means from minus infinite to 0, we replace this inductor to short circuit and do the same stuff here, but initially, right after t bigger than 0, this is not replaced to short circuit, but when it reaches infinite, okay, I mean infinitely big number, we can replace it to short circuit, and what we have is this voltage source, short circuit, and resistor. Okay, so now we can find what? Now we can find I infinite, right? Because at I infinite, this is short circuit, and this equals to what? I infinite what? As we know from Ohm's law, V over R, our V is 24 and our R is 2. So I infinite is 12A. So overall, what we have is IT. Okay, I'm putting our values to the formula. 12 plus I0. I0 is minus 8 minus I infinite 12 e to the power of t over time constant. Time constant is 1 over 10. So it's amperes. So overall, what can we write is this one. This is minus 20, right? Minus 20 e to the power, this goes to up 10t a, and this is equation of time, current with respect to time when t bigger or equals 0. So this is our final solution. So now let's consider okay, so now let's consider the case when we consider RC circuit. Okay, so we have this now. So okay, the case, or how would say algorithm is pretty same. Firstly, in this case, we find V0, okay, because we're considering capacitor RC circuit, we try to find function of VT, okay. Then what we find, this V0 we find when t equals less than 0, okay, t less than 0. Then we find time constant, a formula is RC, when t bigger than 0, right after it goes upper than 0. And what we find, then we find V infinite when t equals infinitely big number, okay? So the formula is pretty same. Vt equals to V not 0, V infinite, okay? Just learn this formula, memorize it, plus V0 minus V infinite, then e to the power minus t theta. It's pretty the same instead of I have V, okay? So let's try to solve this problem. So we're considering the case when t less than 0. So let me draw this part. We have to consider only part when switch is at position A. We'll omit everything which is in the right part of the capacitor. So after t equals 0, switch moves to the B. But until that, we consider only the elements in the diagram when switch is in position A at A, okay? So let me draw only this part, minus 120, and we're going here 40k ohm, and what? And capacitor 25 farad, So we're omitting all of this part because there is what? There's no link, okay? We omit everything in the white part. So, okay, as you can see, when t less than 0, this is the interval of minus infinite to 0. And in this part, we can replace capacitor with open socket. Okay, because in this period, our di dt is 0. So that means I is 0 and I is only 0 when there is open circuit, okay? So I'm redrawing this picture, minus plus 120, this resistor, open circuit, plus minus V0. And in this case, the voltage here equals V0. So we have to find from this diagram V0. And as you can see, V0 is going here. And the V0 is going to be what? V0 is going to be minus 120, right? Okay, let me prove it. So we can see the node voltage method, current always goes to the left because from the definition of node voltage goes kind of out of the node, but no current goes to the open circuit, right? So we only have this current. So this current equals to what? V0 minus, here we have minus 120 because polarity is minus, over what? Over this resistor. And no voltage, no current, yeah. So plus 0, I mean, current here is 0, so everything equals 0. So what we have, we omit this part because we can multiply everything to this value, and what we have is 0 plus 120 equals 0. So overall, our V0 is going to be minus 120. Okay, so let's consider the second case when not V, but sorry, t bigger than 0. So in this part, we redraw the picture. Okay, what we have. So this capacitor. So we omit everything to the left part, okay? Because switch is moved to the position B. So here resistor. The 50K ohm, 2.5 K ohm, 150K ohm, and I guess it's plus minus 75 voltage, okay? Hopefully, oh no, it's 200. Okay, no problem. So from this part, firstly, what we have to find is time constant, okay? So right after t bigger than 0, we don't replace this capacitor to open circuit because it's not infinitely big number, just right after t equals or bigger than 0, okay? We find firstly time constant, and the formula of time constant is such that C capacitor is R equivalent by C. So firstly, we have to find R equivalent. And in this case, we can see that these two resistors are in parallel, right? So our equivalent 50 parallel 150 K ohm, and plus they are in series with 2.5, right? So overall, after calculating this value, we can get 40 K ohm. So now we can find, I mean, this is the first step, the second step, and now we can find time constant. 50K ohm multiplied our capacitor value was 0.35 farad, and overall, after multiplying this, we can get 1/100 seconds. Okay, this is going to be 1 milliseconds. So after t0, when time reaches infinitely big number, we can replace this capacitor with open circuit, okay? So in this case, then we find what? V infinite voltage when time is infinite, okay? Let's say infinitely big number. This part, okay? So let me redraw this part. So we have placed it with open circuit, and the voltage here is the infinite, right? So again, we have these resistors. So what's our objective is now to find the infinite, right? So as you know, we have to apply not voltage method, and there is resistors. Okay, let me read over them. So firstly, let's write it as a reference. Okay, the reference will have 0 voltage, and let me write here V. So current goes to this side, to the down, outgoing current, but no current goes here. I is 0 because there is open circuit, right? So that means our V infinite, or let's say V equals V infinite. Okay, because there's no current, so we can write this here because there's nothing go. I mean, no voltage drop or no voltage rise. Okay, voltage drop or voltage rise, no. So that means nothing's changed through this part. So the value of voltage here and here are same. So we can write instead of V the infinite. Okay, so let's consider then only these two cases. So current going to the right, it's going from V infinite to here is 75 V because polarity is plus. Okay, minus 75 over resistor 50 k ohm plus it's going to the down, so it's going from the infinite to 0 to the ground over 150 k ohm. So everything equals to the 0. So what can we find after solving this equation? You can find out that, okay, let's solve it. Okay, it's going to be here 3, right? 3 minus 75. I mean, they canceled, okay? This and this, it's going to be just 3. So, and this is going to be canceled, it's going to just 1, so equals 0. So what can we find is that 3V infinite minus 5k 5 over this then actually let me think right now. We're doing everything correctly. Actually, there was not 75. Okay, sorry, there was 200, right? I mean, initially, yeah, 200, okay. So here 200, as you can see. So let's put instead of 75, 200. Just realize that something is going wrong. So instead of 75, 200. Well, 200. So 200 multiplied to 3 is going to be 600. And then 4V infinite equals to 600. And our voltage at different times is going to be 150 voltage. So everything's fine. Initially we had to find V0, time constant, and V infinite. So everything are done. So we can now find VT. It's going to be V infinite, it's 150 plus V0 minus V infinite. Actually, it's minus 120k. So then, because we have found it already, so let's say it's 1 minus 120v. What's going to be? It's going to be 1 over 1000 seconds, and it's going to be 150v. So e to the power 1 over this part, this is the value of our time constant, and everything is just v. Okay, so vt equals to 150 minus, this is going to be minus 270. E to the power, this is going to the up, so minus 1000 t, and everything, the value is t. Okay, I mean the value, the output is in voltage, and you can say the interval, and t equals or bigger than 0. So that's it. Hopefully you understood step response of RL and RC circuit, and hope we can find the VT or ITV function for RL and RC circuits respectively. So as a conclusion, in RL circuit, you find both I0, K, time constant, and I infinite. You replace inductor to short circuit, okay? In RC circuit, you find V0, time constant, and V infinite. You replace capacitor to open circuit, okay? Please watch this video carefully. I hope everything is understandable. See you soon in our next tutorials.